Welcome to the Unit 4 Section 2 video on key features of scatterplots. You have examined relationships between sets of ordered pairs or data. Displaying data visually can help you see relationships. A scatterplot is a graph with points plotted to show a possible relationship between two sets of data. A scatterplot is an effective way to display some types of data. So in this example, we're going to use the table to show that the number of hours a student slept and their score on an exam. We're going to use the values in this table to graph a scatter plot. And it's as simple as it sounds. You're going to take your hours slept, these are your x values, and you're going to plot the x value with your y value, the test score. So for our first data point, we would have the ordered pair 883. So you would plot go over 8 on the x-axis, go up 83 on the y-axis, and plot your point. And you would do that for all the points, and you would get a graph that looks like this. And so this is our scatter plot of the data of the number of hours a student slept and their score on an exam. And we can get an idea of what kind of correlation we have between those two sets of data. So just looking at the data that's plotted here, what kind of result do you get here? What kind of conclusion can you draw? Well, looking at this data, it appears that the fewer hours that you sleep, the more likely you are to get a lower grade on your test. The opposite also looks like it's true. It looks like the more hours you get of sleep, the better you will score on your test. And of course, this is assuming all other variables are held constant. So you heard me use the word correlations. We want to describe correlations and how data is related to one another. A correlation describes a relationship between two data sets. A graph may show the correlation between the data. The correlation can help you analyze trends and make predictions. There are three types of correlations between data. You have a positive correlation, negative correlation, and no correlation. So a positive correlation occurs when both sets of data values increase. So it looks like if you were to draw a line that roughly goes through that set of data, that it would be increasing from left to right. A negative correlation occurs when one set of data values increases as the other set decreases. So if you were to draw a line through this data, it looks like it would generally be decreasing from left to right. And then finally, no correlation occurs when there is no relationship between the data sets. So looking at this graph of data, you can't really determine if the data is increasing or decreasing overall. So it looks like there's no correlation or no relationship between the data sets. So let's determine the type of correlation, positive, negative, or no correlation given to the scatter plots. So in this one, we've got data that looks like it's going down, but we also have data that looks like it's going up. So it's hard to draw any conclusions from this, so there is no correlation. In B, it looks like the data is generally going up from left to right, so we have a positive correlation. And in C, we have data that generally looks like it's going down from left to right, so it is a negative correlation. We can also identify correlations between pairs of data by what we would expect to happen. So for this first example, the number of empty seats in a classroom and the number of students seated in the class. Well, you would figure that the number of empty seats in the classroom would decrease as the number of students seated in the class increases. So since one's decreasing and the other's increasing, you would have a negative correlation. The number of pets a person owns and the number of books that person read last year. Well, the two have no connection to one another. A person could read a lot of books or they could read few books over the year, but they may have two pets, they may have no pets. There's no connection between those sets of data, so there is no correlation. And the monthly rainfall and the depth of water in a reservoir, Well, you would expect that as the monthly rainfall increases, you would end up with more water in the reservoir. So since both would be increasing, then you would have a positive correlation. Correlation can also be described by its strength. This provides a more detailed way to describe the correlation of data. The closer the data is to falling along a single line, the stronger the correlation. So we've talked about positive and negative correlation. Now we're going to break it down into perfect, strong, and weak correlation. So you have perfect positive correlation if you have a set of data where you can draw a line through all the data points and you would get one straight line. That's perfect positive. Same thing with perfect negative. If you can draw a line and it hit every single data point and that line does not change how it's oriented, it's just one line, then it's perfect. Now, if you have a few data points that are off of that main line, you can draw a line through it, but you won't hit every data point, but most of them are close, then you have strong correlation, either positive or negative. Now, if the data points drift a little bit farther away from a line that you try to draw, then you have a weak correlation. So you notice that the weaker the correlation, the more spread out your data becomes. So we're going to determine the type of correlation, positive, negative, or no correlation, and the strength of correlation, either perfect, strong, or weak, given the scatter plot. So in A, it looks like if we drew a line through, we wouldn't exactly hit every point. So this is going to be strong correlation because the points are not that far off of the line that we would draw, and it is positive since it's increasing. For B, if we were to draw a line through all the points, it looks like we would hit every single point. So this is perfect negative. For C here, you can tell that it's overall decreasing, but the data is a bit spread out, so this would be weak negative. For D, we have a decreasing set of data, so it would be negative, but if we were to draw a line through, most of those points would be pretty close to that line, so this is strong negative. Now this one, we can't really tell if it's increasing or decreasing, so in this case, we have no correlation. And then for F, it does look like this data is increasing, but the points aren't exactly tight. They're a little bit more spread out, so we have weak positive. You can graph a line on a scatter plot to show a relationship in the data. This line is called a trend line. It helps show the correlation between data sets more clearly. It can also be helpful when making predictions based on the data. To draw a trend line, draw a line that has about the same number of points above and below it. Your line may or may not go through all the data points. So in this example, the scatter plot shows a relationship between the total amount of money collected and the total number of rolls of wrapping paper sold as a school fundraiser. Based on this relationship, predict how much money will be collected when 175 rolls have been sold. So we have the scatter plot, and we have our trend line, which is that solid line going through the data. What you will do is find 175 rolls on the x-axis. You will follow it up, which is indicated by the dashed line. Follow it up to your trend line, and then once you hit your trend line, follow it back to the y-axis to find your estimate of the money raised. So based on the data, $1,200 is a reasonable prediction of how much money will be collected when 175 rolls have been sold. Once a trend line is drawn, the equation of the trend line can be determined by identifying the slope and the y-intercept. The equation can be used to determine the output for any input. So in example 6, Angie enjoys putting jigsaw puzzles together. The scatter plot shows the number of puzzle pieces and the time in minutes it took her to complete each of her last 6 puzzles. Write an equation of the trend line and use it to estimate the time in minutes it will take Angie to complete the 2,000-piece puzzle. So we're going to find our slope first. You have to do your change in y over your change in x. So for every 100 we go up, we run 200. Now it is important in these types of graphs to look at the scales on both of your axes. Each grid may not indicate one. So in this case, the y-axis, every grid line is 100. On the x-axis, every grid line is 200. So we get a slope of 1/2 when we reduce it. Our y-intercept is 0. So since we know our slope and we know our y-intercept, we can use that to find our equation in slope-intercept form. And we can plug in our value for x, which is our puzzle pieces, to find our y, which is how much time it would take to put together the puzzle. So based on the data, it will take Angie about 1,000 minutes to complete a 200 or a 2,000 piece puzzle. Recall, the slope represents a rate of change, and the y-intercept is some starting value or flat fee. These key features remain the same for the trend line of scatter plots. Students graphed a scatter plot for the temperature of hot bath water and the time if no new water is added. Describe what the slope and y-intercept mean. So here we're going to do some interpretation. Our slope is rise over run. So our rise here would be our water temperature, which is our y-axis, and our run is time, which is our x-axis. So the amount of water temperature falls over time is what our slope represents. And the reason we say fall is because our slope is decreasing. We have a negative slope in this graph. The y-intercept is the starting temperature of the water before the temperature begins to drop. Thanks for checking out my video in the Algebra 1 Honor Series. You can subscribe to my channel. I've got the next video queued up for you. And if you need to check out any of the videos in the course, I've got the course playlist for you here as well. Thanks for watching.